Hello my dear champions, welcome back to our channel Deeksha Karnataka. I hope you are doing great. Okay, so today I'm here with the one shot lecture, the theory lecture of the chapter sets and relation and function. Okay, two simple chapters of PU1. So let's start learning the theory part, as you were all asking for your maths theory and for other subjects as well. So I hope you are getting the Masterstroke series and you are able to learn the theory at the same time. Okay, of course question practice are already been done, but if you want to solve more questions, if you want to solve and prepare yourself in the best way for KCET and compete with the toppers and the rankers, do not forget to check out our ABHYAS KCET test series. Okay, it's available for 999. You can take it up right now in the the link is given in the description of this particular video. Go and check it out and you will find the test series link. Do not forget to check it out, ABHYAS KCET test series. The price for the ABHYAS, one second guys, so price for the ABHYAS test series is 999. So please check it out if you wish to solve more questions and prepare in the best way possible for CET. Check it out and start solving the questions. Okay, so I think we are ready. Let's start the class. Hello my dear champions, welcome back to the crash course. Today I'm here to discuss your first 4 chapters in PU1 syllabus. The chapters are very simple: sets, relation and functions, trigonometry and complex numbers. They are simple, but we'll still not skip anything. We'll cover up all the portions. I understand the weightage is less over here, but it's relatively easier to what we have in PU2 portions, so it will not take much of our time. So I've clubbed these 4 chapters together in this particular part and we'll see all of them at once. Okay, starting with the first chapter, which is your sets. Okay, it's a very simple chapter. We learn over here about your definitions or individual sets, 2 forms, which is the set builder and rooster form. We use the operations on set, whether it is union, intersection, Venn diagrams, and of course we use that later in Cartesian product when it comes to the ordered pair and relation and functions. We'll see that again in this particular session itself. So let us begin with the class right away. Okay, so here it is. First, definitions, and very important to know all the notations for all these very important standard sets that we have. N represents your natural number set. I hope you all know that. Next we have W for whole numbers, Z for integers, Q for rational numbers, yes, Q for rational numbers, and we have R for the set of real numbers. Z plus represents only positive integer. Will 0 come over here? No. Z plus means only positive. Is 0 positive beta? It's not. It means it will not be over here. Again, if I write Z minus, will it be having 0? No. So when we say Z plus or Z minus, it means only positive of whatever it is, integer, rational and real numbers. Okay, I hope this is making very much clear. These are very well defined and standard sets that we need to know in order to solve any questions in set theory. Okay, moving on. Next, some of the formulas, as I mentioned, we're going to start with the basic 2 forms that we have, set builder form and the rooster form. In this, we write the individual values. We don't write a relation, we don't write a property of the set. Instead, we write the individual element of the set together in the middle bracket. That is called as your rooster form or tabular form. Means each of these are the elements of the set. Means 2 is part of that set, 5 is part of that set, 7 and 11 is also part of the set. Does it make sense? Yes sir. What about set builder form? Over here you'll have a property, you'll have a definition which can give you a result. For example, set of all natural even numbers. Okay, even numbers are natural only, so set of all even numbers. I can write here as set A, X is the element of what? Set A, of course, where, sorry, what is it? X is, sorry, my bad, not A. I'll write here the natural number, no? Yeah, only natural numbers, and X is even. This is how we can write one of the examples for set builder form. Okay, or basically in the simpler terms we call it rule form. Example, if I have to write the same in the form of your roster, then I'll write this as again middle brackets. Answer will start from 2, 4, 6, 8, 10. Will it end, sir? No, it will not end because we have not defined any limit. If I would have said that even number less than 12, then it is okay. Then I'll have to stop at 10, but I have not defined anything as such, have I? No. In that case, the set will be an infinite set. So again, the next definition comes from here, which is finite and infinite set. A finite set is a set which has fixed number of elements in it, whereas infinite set is a set which has not unfixed number or infinite number of elements in the set. Okay, so then let's go with the next set of definitions. We have empty set. A set does not have anything in it, even 0. If I put here, if you ask me, sir, what about you write this, will this be empty set, sir? Will this be empty set? My answer is no. This is not an empty set, okay? Because empty set means it should have nothing in it. If you write 0, it means still have one element which is 0 in it, okay? Empty set or null set, or sometimes we also call it as a void set, okay, is a set which has no element in it, not even 0, okay? Sorry. So this is clear. Finite, infinite, already explained it to you. Finite means a fixed number of elements in it. Infinite means, of course, which has not a fixed number of elements, just opposite, okay? Here you can see there are 3 elements. This is the finite set, and infinite set, we can look at example over here. 3, 6, 9, it is not ending, so infinite set, okay? Singleton set, a set having, as the name suggests, single element. If a set has only one element, it will be called as what? It will be called as your singleton set. Example, X is the capital of Haryana. Okay, yes, set can have element, not only numbers, it can have, letters also, words also. Set of anything can be there, right? Okay, the capital of Haryana, Chandigarh. So how many numbers can be there? Can a state have 2 capital? Not possible. So that's why it is going to be a set of single element, hence singleton set. So these are very straightforward, simple definitions, may not be asked straight away in the questions, but what happens is they all play a role understanding the whole chapter and solving questions from here. Not only the questions of sets, but also in relation and function, which is one of the high weighted chapters of your syllabus. I hope you know that relation and function of PU1 alongside trigonometry of PU1 are the high weighted chapters of PU1 syllabus. When I say high weightage, means more than one questions will be coming, okay? Cardinal number. Cardinal number is as simple as it gets. The number of element in a set is called as cardinal number. I think I have used it at multiple occasions in our previous classes also in our PU2 syllabus. So cardinal number is simply the order of a set, or basically your number of element in a finite set. Because of course you cannot define number of element in an infinite set, right? Okay. Examples are written over here. Let's look at some notes. The cardinal number of the empty set is always 0, okay, and the cardinal number of a singleton set is 1, and the cardinal number of infinite set is not defined because we cannot define any number. We cannot associate a number of element in a infinite set, sir. So these are pretty obvious notes, but just making a point of it for all of you. Equal sets are the sets which has same number of elements alongside with same values in the element. Example over here. Exactly, let me show you. Yeah, so 2 sets A and B are said to be equal if they contain exactly the same elements and can be written as set A equals set B. Example, you check A, C, D, E, D, E, C, A. The way we are writing, the order may be different, but the elements are, the arrangement might be different, but elements are how many over here? If you ask, so N of A is, sir, 4, and check carefully, this is equal to N of B. This is the first statement, and also they are identical elements. Identical element. Okay, when both of the conditions are true at the same time, then we call the set to be what? The set to be equal set. If you have only first statement true, it means if the cardinal value, it means if the number of elements in 2 different sets are equal, but they are not the same elements in 2 different sets, then the set becomes not equal but equivalent set. Okay, if you have in 2 finite sets the NA value and NB value equal, then it becomes a equivalent set. Okay, come on, let's look at the note. 2 finite equal sets are always 2 finite and equal sets are always equivalent, but two equivalent set may or may not be equal. Example, I can write 1, 2, 3, 4 and I can write 2, 3, 4, 6. Both have the same element, same number of element, which is 4. 1, 2, 3, 4 and 2, 3, 4, 6. So number of element is 4 in both the sets, but the sets does not have exact or identical element. Okay, so the equivalent set may or may not be equal, but all the equal sets will every time equivalent. Okay, next, a set does not change if one or more element of the set are repeated. Okay, because when you write a set, no, we don't repeat element actually. So if you write A, B, B, C, C or A, B, C, they are the same thing. We don't repeat the elements actually. So just because they have written like this, sir, what about A, B, B, C, C? Then what is the cardinal number of this set? It's still 3 only. It's not 5. Okay, getting my point? Next, subsets. This is an important concept, so please pay attention. Subset and proper subsets are also important, so we'll go through that one by one. Let A and B be any two sets, then A is called a subset of B if every element in A is contained in B. What does it mean, sir? It means if an element, let's say 1 is present in set A, if the element 1 is present in set A, then in the set B 1 will be present. If the element 2 is present in the set A, then 2 will be present over here. If we have 3, we'll have 3 over here. Okay, we'll have 3 over here. Means every element in the set A will be present in set B, and set B can have more elements than the element of 3 as well. We can have 5, 6 and more elements like that. Okay, but a minimum of 1, 2, 3 must be there. If that happens, then we call the set A to be a subset of B. A subset of B. The symbol is very simple. A is a subset of B. This symbol is for subset. Now something interesting I'll teach you over here only. You can see the definition on the next slide. Something called as proper subset. Proper subset. This is something which has a symbol, of course, like this. You don't have a line below, and in this case there must be one element extra, minimum of 1 element extra in the set B. Means, so over here if you check over this case, actually A is the proper subset of B. Sir, it did not make sense. I always make mistakes in questions like this. Every time every teacher has taught me this, but I keep making this mistake. I don't have the clarity in this concept. It's okay. Wait a minute, then you will have. Understand this. If I write beta, let's say I'm writing another set C over here. 1, 2 and 3. If I say A is a subset of C, answer is true. Okay, but if I say A is a proper subset of C, this is false. That's the definition. I hope this is clear. The symbols are very important. Okay, this represents your subset and this only represents your proper subset. If A and C are like this, then A will not be a proper subset of C, because proper subset of C means that in the set C there must be a minimum of 1 extra element to what is present in the set A. Does it make sense now? In the set C there must be at least 1 extra element than what was present in set A, then only set C and set A will have the relation of A is a proper subset of C. Otherwise, we'll say simply A is a subset of C. And what is that called as? Basically, it's called as, I can write this as A is improper. A is improper subset of C. But over here, for this we can write A is proper subset of B. I hope it is clear now. If the set B has 1 extra element, a minimum of 1 extra element, then A becomes a proper subset. Since set C was not having any extra element, then the set A becomes improper subset. Okay, now whenever the concept of proper subset comes, then actually this is important. Check here. Then the set B is superset of A. Since A is proper subset of B, then B becomes a superset of the set A. That is it. Let's read this notes. Every set is a subset of itself. Correct, sir? Every set is a subset of itself? Of course, yeah. Every empty set is a subset of every set. Because if you write the subsets of any set, for example, let's write this set which has only one element 1. Let's write the subsets of these sets, subsets. We can have two cases. We can have nothing in it and we can have one in it. So check here, this is defined. This is what? This is a empty set. This is a empty set. So even empty set is a subset of one. So empty set is a subset of every set. And check here, this is the set itself. So every set is a subset of itself. So I hope this example where I've taken a set with the element 1, it has only two subsets. One subset is the empty set and the other subset is the set itself. I'll repeat. The set I've taken as the set with only one element 1. It has two subsets. One subset is what? Is the set which is the empty set. Okay, another one is the set itself. Okay, so the first two definitions in the notes are defined. Every set is a subset of itself. One are same, no? So every set is a subset of itself, and also every empty set is a subset of every set. Okay, so empty set is a subset of every set. Next, let A and B be two sets. Then if A is a subset of B and A belongs to the first set, small a belongs to the first set, and this would be small b actually. Okay, A belongs to B also. Okay, correct. Sorry, this is nothing but if A is a subset of B and the element belongs to the set A, then element will also belong to set B. Make sense? No? Think about it. If I write a set A as 1, 2, and I'm saying A is a subset of B, it means that set B will have 1, 2 and maybe other things. Correct or not? Set B will have 1, 2 and maybe other things. So if I say that A is the element of 1, 1 is the element of set A, 2 is the element of set A, then 1 and 2 are also element of set B as well. Yes or no? Yes, same thing. If A is the element of set A, then A will also be an element of set B, provided that set A is a subset of set B. Next. If A is a subset of B, then n of A will be always less than or equal to n of B. Either less than or equal to. Check here. This is the case of less than. This represents n of A is less than n of B, and this represents the case of n of A is equal to n of C. Equal case and the less than case, but it can never be more. Okay, so n of A will be always less than n of B, and if n of A is more than n of B, then it cannot be subset. It cannot be subset. A cannot be subset of B. In that case, it will become what? B will be subset of A. If it is true, A is subset of B and B subset of A, it means that A and B will be equal. Also, vice versa is true. Total number of subset of a finite set. This is also a definition of power of a set. Power of a set is defined by 2 power n. Power of set is defined by 2 power n. So simple definitions, but it's very important to know every aspect of it. Proper subset I already taught you over here because I wanted to teach you subsets at the same time. So I already taught you proper subset. You can go ahead and explain it, understand this again by reading the statements. I'll help you, don't worry. Let A and B, let A be any set, okay, and B be a non-empty set, then A is called as proper subset if every member of A is also member of B. That is the first thing. But there exists at least one element in B which is not a member of B, means something extra is present. Okay, nothing different. Some notes to check over here, beta. The subset which is not proper is called as improper subset. How can you say that, sir? This is proper, that is improper. Proper because something extra was here. Nothing extra means improper. Okay, makes sense? Yes, sir. Number of proper subset of a set containing n element is given by 2 power n minus 1. What is this one, sir? This one represents set itself. Okay, set itself, because if it is set itself means it will become equal case. right or not? If you take set itself, it becomes equal case. So you have to omit that part. That's why we have removed -1. What is 2 power n? This represents total number of subsets. Yeah, think about it. 2 power n represents total number of subset. Why -1, sir? Because if you take the set itself, then it becomes what? Then it becomes, sir, equal. It will not be a proper set anymore, proper subset anymore, but we are looking for proper subset. Proper subset means it should be smaller than what it is. Okay, in that case, we got to remove the set itself. That's why -1. Because we just learned right now, every set is a subset of itself. So you have to remove that one set, right? That itself, because we want the cardinal number to be less, not equal. Okay, in the case of proper subset, every set has only one improper subset, which is the set itself. Set itself. I hope this makes sense. Oh, I hope this makes sense. Every proper subset is a subset of subset, but every subset may or may not be a proper subset, of course, right? Means every proper subset is a subset, but every subset may or may not be a proper subset, because we should have a case, no? It can also be, because subset has two branches. It has two branches, proper and improper. A subset has two branches. Proper, improper means every proper subset is a subset. But will every subset be a proper subset? No, some of it might be improper also. That's why a subset may or may not be a proper subset. I hope this is clear. Next, intervals of a subset of a real number, of a relation. Okay. All right. Let a and b be any two real numbers. A is less than b. I write a over here. Then this is called as closed interval when the values a and b are both inclusive. So let's say if I'm writing here x, okay, x represents the element, then x will lie from where to where? A close to b close. A close to b close. We write them using the close bracket. A close to b close. Please check. Okay, same way, open means what? We'll keep the inequality x with the open sign. So a open to b open means a and b are not inclusive, and over here we'll use the simple small brackets, not the square brackets. Okay. Next, close open means at a will have close and at b will have open. So x will be more than equal to a and less than b. At b it is open, and just opposite over here, x is less than equal to b and more than or greater than a. At a it is open. But I know it makes sense to all of you. It is a very simple concept, but it is used a lot everywhere, right? And also in the chapter inequalities. Let's move on to the few more definitions. Universal set, a non-empty set of which all the set under considerations are subsets. Means you take any sets A, B, C, whatever you're talking about, all those sets will be a subset of the universal set, or will be subset of that particular set. Then that set becomes is called as a universal set. For example, my question to all of you, think about it. Is natural number a subset of real numbers? Answer is yes. Hence, for this particular case, the natural number is a subset and the real number becomes your universal set. So natural number, whole number, integers, all these, even irrational number and rational number. I'll repeat. Natural number, whole number, integers, rational number, irrational number, all these are the subset of the set real numbers. Okay, so real number becomes universal set over there. But if I go and increase that also, then real number will also be a subset of a complex number, because for complex number you will have real and imaginary both. For example, yeah, explaining the same thing, set of integers, the universal relation will be what? Universal set will be the real numbers. Okay, look at the examples, not a problem, simple ones. Venn diagrams. Same thing I can relate to the Venn diagrams also, you can check. Okay, sir. Natural number, whole numbers, integers, what is this going to be? I can write here, I cannot write them together, no, rational, irrational. Okay, so let's go and write here simply real numbers. Okay, or I can remove this. Usually what we do is we write the universe with the help of a rectangle. Real numbers. So R represents your what is it? Your universal set, where N, W, Z are all the events or the sets inside the universal set. The Venn diagram helps us understand the relationship between the different sets, okay, using pictorial representation, including the intersection, including the union, and all those things. Okay, so we get to have the understanding of subsets and everything. Okay, operations on set. Union of set. The union of set is what? When you combine the elements of two sets without repetition. Very important. The statement is very important. Without repetition. Here being taken only once. You cannot take or repeat an element. Example: 1, 2, 3, 4, 3, 4, 5, 6. Check here. 3, 4, 3, 4 repeats. Sir, will we keep this 2 times? No. Will we keep it no times? No. We'll keep it only once. So answer will be 1, 2, 3, 4, 5, 6. This represents a union. So you got to remove the repetition. That's what it matters. You got to combine all the elements of all the sets that you're talking about in the union, but you got to remove the repetition. Properties of union set. Okay, union of a set. Cumulative law means union of A and B same as union of B and A. A and B with union C can be taken in any other form, means the associative law is also true over here. If you take union of A and the null set, result is simply the set A itself. Okay, it's called as law of identity of element, and phi is the identity of union. Okay, check here. And what is this? A and A will be A itself. This is idempotent law. And union of universal set with, this is not UU, this represents your universal set. Universal set with the set A is always universal set. This is the law of universal set. Okay, moving on. Intersection of two sets. What is the meaning of intersection of two sets? Means when you look for the common elements. Okay, 1, 2, 5, 6, 2, 3, 4, 5. The common element is 2 and 5. The common element is 2 and 5. Please have a look. Right? Okay, that's it. Properties of intersection of set. This is important. So in A intersection B is same as B intersection A. Commutative law is true over here. Next is intersection of A, B, C can be taken in any other form. Means A, B together, then C, or A first with the combination of B and C. This is associative law. Okay. Intersection of null set with A will be giving me null set. And intersection of universal set with A will giving me, what is it? The set A itself. Law of null set and universal set. Idempotent law will remain again same. A with A will be giving me A if you take intersection of A and A. Okay. A intersection with B union C given by A intersection with B union A intersection with C. Distributive law of intersection over union. Intersection over union. Okay. Intersection distributes over union. Disjoint sets means nothing in common. When the intersection is null set or nothing is in common, okay, are called as disjoint sets. Difference of sets. This is very simple. Just that all which is present in A and that is absent in B is called as difference of sets. Check here: 1, 2, 4, 5, 6, 4, 6, 7, 8, 9. So always listen to me very carefully. Present in A, absent in B. Present in A, absent in B. Don't think about present in B, okay? If you're writing A minus B, it represents present in A and absent in B. Think about it. One is present over here, one is not over here. It means my first element will be 1. 2 is there, 2 is not here. My second element will be 2. 4 is there, 5 is not here, means 5 will come. 6 is here. So answer is 1, 2, 5. Answer is 1, 2, 5. Present in A and absent in the set B. Properties of difference of sets. Properties of difference of sets. Have a look. A minus A is equals to null set. A minus null set is the set itself. A minus B intersection C is A minus B union A minus C, and A minus B union C is given by A minus B intersection A minus C. Okay. Now, very interesting. Symmetric difference of sets just represents this, the set of all elements that are in either set but not in both. That's the definition. Again, you can use this and everything which is given in the screen, but this will help you solve all the questions. Representation is what? Representation of this is given by A delta V. This is called as symmetric difference between two sets. Okay, what is the answer? Set of those elements which are present in either of them but not in both. Means you have to remove what? Basically you have to remove what? The intersections, right? Means it cannot be the element which are present in both. Just remove the intersections. That's your answer. Okay, correct, sir. Complement of a set, have a look. So if I'm talking about A complement, it represents universe minus A. Universe minus A, as simple as that. We write A complement, we write A dash or A bar or U minus A. It's all the same thing. Okay, everything but the elements in the set A. Everything in universe but the element in set A. Properties of complement. Okay, A union with A complement is, what is it? A union with A dash. A is there, union with A dash. A dash means U minus A. Add them. A plus U minus A. Cancel. What's the answer? U itself. Answer is U itself. Okay. A intersection with A dash means, intersection means common between A and not A. What is the answer? Think logically. Wait for a second. Intersection means common between A and not A. Nothing is in common. Answer is null set. De Morgan's law. Okay. A and then B dash is given by A dash intersection B dash. Very important. We use this in probability also. And A intersection B dash is given by A dash union B dash. Law of double complement. This we know very well. If you take complement on the complement, it gets back to the same set A. Okay, yeah. Then laws of empty set and universal set. Phi dash is U and U dash is phi. Means everything but null set is universal set. Everything but universal set is null set. Okay, great, sir. Let's solve a couple of questions on it before moving to the next chapter. Which of the following is not a singleton set? Means which does not have one element in it. X mod of x as 3, it will give me two answers. Mod of x as 3 if you take, then x becomes what beta? Plus minus 3. But in this case we have only natural numbers, then we cannot take x not equal to minus 3 because x belongs to only natural number. It means the answer is only equal to 3. So this is a singleton set. It has only one element in it. Okay, look at this. X square equals to 4. It means x is equals to plus minus 2, right? And this belongs to what? X belongs to integers. Means I can have both values. 2 and minus 2 are both true. Is this a singleton set? No, it has two elements. It is no longer having only one element in it. It means it becomes what? A non-singleton set. Hence answer is option D. Answer is option D. Which of the following has only one subset? Okay, think about it. How many subsets are there, Vicha? Over here, I said every set is a subset of itself. Means I'll repeat this. And even the null set is a subset of every set. Means for the set which has only one element 0, it has two subsets. I'm looking for a case which has only one subset, and that is this case. What is this? This is a null set. This is a null set, and we have learned that every set has a subset of itself. Okay, it means this is the subset also. Hence the answer is every other element if you take will have more than one. This will have the same set 4 and null set also. This will have set 4, set 5, set of 4, 5 and 0. It has 4, total of 4, right? We just learnt about this. 2 power n represents power of a set. Power of a set. 2 power n. What is n value? Total number of element is 2. 2 power 2 will give me 4. This is the number of subset. In this case, what is the answer, beta? Please check. What is the number of element over here? 0. So 2 power 0 is 1. You can use either the concept that I gave you or the formula that I gave you, your choice. Okay, both are valid. Set A is given, set B is given. Okay, A, B set of prime numbers, C set of positive. Set A is given 1, 2, 3, 4. Set B set of prime numbers, so 2, 3, 5, 7, 11 and so on. C is a set of positive odd numbers, 1, 3, 5, 7, 9. Okay, then L is what? Okay, L is a universal set. I'm looking for inverse of both. All this. Natural number is true, even Z is true, all real is also true. Answer is D. If you take the natural number set, all of these are contained in natural number set. Take integer set, all these are part of integer set, so Z can be also universal set. And take this C also, real numbers, all these are real numbers also. It means all the three are correct options, hence the option D is right. Okay, all of these. If A is given like this, B is given, then A minus B minus C. Let's look for A minus B first. So A minus B means that all in present in A but not in B. Present in A but not in B, so A 1 is present, here it is missing, 2 also is present, here it is missing, 3, 4 is there, so that's A minus B. And A minus B minus C means present in A minus B but missing in C. So 1, 2 only, here also 1, 2 only, check here. Because 4, 5, 7 is, 7, 8 is not present in C. So 1, 2 only, answer is option D. Please check. The same concept, present in the set A, absent in set B, present in the set A minus B and absent in set C. Definition remains same. Okay, moving on. Next is the relation and function. The next chapter is relations and functions. Okay, let's start. So let us start. Ordered pair. The simple concept. If A and B is a pair of numbers, then the order in which they appear is called as ordered pair. Okay, for example, if I take 1, 2, 2, 1, they are both different ordered pairs. If I take minus 1, 3 and 3 minus 1, again different ordered pairs, 5, 7. So all these are examples of the ordered pairs. Okay, so when you take Cartesian product of two sets, you end up with ordered pairs. For example, let's say I have a set A which is only one element 1 and set B has two element 2 and 5, and if I'm writing here Cartesian product of set A and B, this is called as Cartesian product of set A and B. In the Cartesian product of set A and B, we don't multiply as a result of product, we get the ordered pair. So if you write this, you'll get first ordered pair as 1 cross 2 means 1 comma 2, then you get 1 comma 5. So this will be your Cartesian product of set A and B, where set A is 1 and set B is 2 comma 5. Getting it? You will not have 5 comma 1 because you're multiplying A to B, not to B to A. If you're thinking, sir, what about 2 1 and 5 1? You'll not have that. You'll have that in B cross A. Okay, this is your Cartesian product of A cross B, which is the next concept. Cartesian product of two sets. Okay, so for all the elements present which is belonging to the set A, for all the small a belonging to the set A and all the small b belonging to the set B, then A comma B is called as, all A comma B, the all ordered pairs, is called as your Cartesian product of set A cross B. Same, A belongs to small capital set or set A and small b belongs to the or is the element of set B. Confusing? Not really, right? I give example first. For all the elements of set A and set B, if you write the ordered pairs in that way, A cross B means the element of set A should come first, then the element of set B should repeat in the Cartesian product or in the ordered pair, that is the Cartesian product of the two sets A cross B. Okay, where A is called as the first element and B is called as the second element of the ordered pair A cross B. Next, properties of Cartesian product, very important, very important. Please pay attention. If A and B are finite sets, okay, means they have the fixed number of elements in both A and B, then n of A cross B, what is n of A cross B? Cardinal number of A cross B is given by n of A, n of B. Means cardinal number of A into cardinal number of B. Check over here. n of a cross b. Let's verify, no, why to keep this to chance. N of a cross b means how many elements are there, sir, over here? Sir, 4. No, only 2. You look for ordered pairs. You look for ordered pair. N of a cross b is 2. What is n of a, sir? N of a is 1, sir, and n of b is 2, sir. Total number of elements in set B is 2. Total number of elements in set A is 1. Multiply this, beta. N of A into n of B will be 1 into 2. Answer becomes 2. Check, are they same or not? So n of A cross B is equal to n of A into n of B for all finite sets. Yeah? Okay. If either A or B is an infinite set, then A cross B is an infinite set. Okay, means if A is infinite or B is infinite, then A cross B, the Cartesian product will also be an infinite set. Okay, makes sense. If A cross B is null set, then either A is null set or B is null set. For any three sets A, B, C, the properties are like this. For union, A cross B union C is A cross B union A cross C. Again, Cartesian product of A with intersection is like this: A cross B intersection of A cross C. The intersection of A cross C, correct? A cross B and B cross A are equal means A and B are equal. That's why I said that you cannot take 1 2 5 1 2 1 5 as 2 1 5 1. It is not possible. Okay, that's a different thing. If I take here 2 1 and 5 1 ordered pairs. Okay, then this will be B cross A actually. This will not be A cross B. If a case has that A cross B and B cross A are equal, in this one, B cross A and A cross B are not equal. B cross A is something different and A cross B is something different. They're not the same. When you have a situation where A cross B and B cross A are equal, it actually means that set A and set B are equal sets. Okay, if Cartesian product of two sets given like this, A cross B and B cross A are equal, then A and B are the same set. Okay, sir. Moving on. Okay, here. So here I've given you some examples to verify this. I want you to break your head, means apply the learnings, because I'm teaching you a concept right now, and it's very easy to get it lost. Because you're learning a concept, you're not practicing right now as of this moment, then you might forget things. So that's why I've given you examples of the sets over here. You have to verify these properties using these sets. It's completely doable, very easy. I'm going to explain it to you as well, but you have to apply your learnings, very, very important. Okay, so promise me you will go back and still work on these sets. Okay, sets ABC, sets AB I've given over here. Let's go back to the first one. If A is a subset of B, not proper subset of B, then A cross A is subset of A cross B intersection B cross A. What you have to do? Simply find A cross B first. So 1, 1, 1, 2, 1, 3. Then you start with 2. 2, 1, 2, 2, 2, 3. This is your A cross B. Same way, find B cross A also. So 1, 1, 1, 2. 2, 1, 2, 2, 3, 1, 3, 2, and take their intersection. You'll get 1, 1 and 2, 2 present. So A cross A, if A is a subset of B, let me repeat, if A is a subset of B, then A cross A will be a subset of intersection of A cross B and B cross A. Looks difficult? It is not. Simply find the A cross B and B cross A value, take intersection, and you will find that A cross A is a subset of that particular result. Okay, moving on. Same thing in the case where we have set C, use this value also. If A is a subset of B, then A cross C, what is A cross C? 1, 4, 2, 4 is subset of B cross C also. What is B cross C, sir? 1, 4, 2, 4, 3, 4. This is so clearly evident from here only. If it is not evident, take a piece of pen and paper and start solving it right now. Okay? Next, for any two sets A and B, A cross B intersection B cross A is equals to A intersection B cross B intersection A. Do these things, please. Note, if A and B have the n elements, this is representing number of elements, okay, in common. if A and B have n elements in common, check here, I have taken 1 2 1 2 common, okay, then number of elements common to A cross B and B cross A is n square. So what is your task now? Check here, what is n in this case? N value is 2. Number of elements common over here is 2. Find A cross B. How can you find A cross B? Sir, 1, 1, 2, 1, 1, 2, 1, 4, 2, 1, 2, 2, 2, 4. Like this you write all the ordered pairs for A cross B. Write all the ordered pairs for A cross B. And same way write the ordered pairs for B cross A. Please write this. Okay, when you do all of this, then you will end up with what? Then you will end up with the results which is common, and that value will be what? N square. That value will be N square. Okay, please check. Next, relations. Now we are getting into, first we are dealing with Cartesian product of two sets, means still we are dealing with sets only, but now we get into relations and functions part. Okay, definition. Let X and Y be two non-empty sets. Of course, to define relation or function, we need sets, okay, because we're gonna call one of them to be domain, range, and later also codomain. Okay, then X and Y are two non-empty sets. Then subset of X cross Y is called a relation from X to Y. Subset of X cross Y means, what is X cross Y means? What does this mean? This means the Cartesian product of X cross Y. Okay, so every subset of X cross Y which can be defined with certain rule or understanding, that becomes a relation. Okay, this subset is obtained by describing a relationship between the first element and the second element of the ordered pair. Whatever ordered pair you form, because whenever you take Cartesian product, what you get? Ordered pairs only. So whatever ordered pairs you are using as subset, means you get, let's say, hundreds of ordered pair. Out of that you picked 5 of them. Okay, out of it you picked 5 of them. Okay, then for example I'm going to take like this. Let's say I'll take here, let's say I'm talking about natural numbers. These are both natural numbers. Okay, I'm not talking about these ordered pairs. 1 1 2 8 3, then 27 4 64. That's it. Means I'm talking about the number and its cube less than 100. Number and its cube less than 100. This becomes my relation, sir. This becomes my relation, sir. Getting it or not? Means both the elements in the ordered pair are natural numbers, but this should be what? Number and their cubes less than 100. This makes a certain rule. This makes a certain relation defined on what? So many ordered pairs that we can make. Okay, if I think of all numbers less than 100, how many ordered pairs we can make? Let me know that as well. Okay, okay. So think about it. Write on the paper. Let me know. Okay, you can always come back to me and give me the answers. Okay, the ways to that in the live classes. Then a subset of X and Y is called. Okay, this is done, sir. Okay. Then the first, the subset is obtained by describing the relationship between the first element and second element, also discussed. The second element is called as image of the first element, and the first element is called as the pre-image of the second element. Second element is image of the first element, and first element is called as pre-image of the second element. Okay. Domain is the set of all first elements. Range is set of all second elements, and codomain is whole set B or the set Y over here is called as codomain. Okay, in this case we don't have B, we have the set Y, so the whole set Y becomes your codomain. What is your set? What is your range? All the set of second elements of ordered pair. What is domain? All the set of first elements of the ordered pair of the given relation becomes your domain. So I hope this is clear. Domain, range, and codomain. Okay, moving on. Okay, the total number of relations that can be defined from a set A to B, set B, the number of positive subset of A cross P, okay, is given by 2 power P cross Q or P into Q. If P represents the cardinal number of the set A and Q represents the cardinal number of set B, then the relation is given by, the total number of relation is given by 2 power P into Q. Okay, note. Relation R from A to A is read as relation on A or relation in A. Okay, range is always a subset of codomain because range represents the second element of the ordered pair, where what is the codomain? All the set B or set Y. Okay, got it, sir. Great. Functions. Now we're moving to the functions. A certain type of relations are called as functions, which follow the property that every element in the domain will be having a unique mapping, a unique relation or unique numbers mapped in the codomain. I'll read the statement for you. Let A and B be two non-empty sets. A correspondence between or mapping. We can write a simple word for this. A mapping or relation. Okay, between the elements of A and B is called a function from A to B if for each element of A there exists one and only one element in the set B. Means that if I try to show you with using the mapping, I can have mappings like this. Means I can have mappings like this. 1, let's say 1, 2, let's say we have 8, 3, let's say we have 27. If I talk about cube of numbers, can you have a same number cube as two different values? You can't have that. Okay, you can't have that. Okay, if I talk about square, let's say, then it will be different, right? -1, 1, 2, 2, you will have 4. Okay, so we'll go like this. Again, for the element 2, the number is mapped only to one element in the set B or the codomain. You will not have this result. You'll never have this result. Let's say 1, 2, 3, 4, 5, 7. 1 will not be mapped to what? 4 and 5 both. 2 will not be mapped to what? 5 and 7 both. This is not possible. Means a single element in the set over here, set A, will not have two distinct images in set B. Okay, means 1 1 is okay, many 1 is also okay, but 1 many, no. Means single element in the domain will not have two distinct images in the codomain. Is it making sense now? So I have given you all the mappings, though this is not a function. This is a function, and so is this also. Getting it? Now what type of function is that, whether 1 1 or 2, that is already discussed in your PU2 syllabus. This is just to talk about how to define a function. I have taken care of that using these mappings that is present on your screen. Okay, sir. All right. Okay. The function is also named as map or mappings. A function from set A to set B is denoted by F A arrow to B. Okay, where A represents your domain, B represents not range, codomain. A is domain, B is codomain. B is codomain, not range. Range is what? Range is the y coordinates of all the inputs, basically set of all the images of the element of set A. I'll repeat, set of all the images of the element of set A are called as your range. Okay, nothing different. Great, sir. Range of f is what? F of x. X belongs to all numbers. Means what does f of x represents? The images, the function values. Range of function is subset of codomain. Already explained it to you. Yeah. Note, a function is always a relation, but a relation is not always a function. Okay, correct. Because we may or may not have this mapping. That's why it depends like this. Some important functions. Now we have some standard functions to deal with. Let's quickly look at them. Very simple. We'll talk about the domain and range and the graphs also. We'll talk about domain, range of some standard functions alongside the graphs. First one is identity function. When y equals to x we have. Okay, means if you take x value as 1, y value is also 1. When you take x value is 2, y value is 2, and so on, the graph looks like this. Y equal to x passes through the origin at an angle of inclination as 45 degrees to both x and y axis. Okay, great. Domain is all real numbers. Domain is all real number, and codomain and range is also a all real number. This is codomain, by the way. Range is also all real. Okay, moving on. Constant function, it will be a function, can be anywhere. Over here means y equals to some constant, 3, 5, minus 3, minus 3.5, and so on. Okay, so over here the domain will be all real number and range will be fixed to only that particular value, 3 or 3.5, whatever it is given to us. Okay, so this is clear. Range is constant and domain is all real numbers. Polynomial function. Polynomial function is again given by this a0 plus a1x plus a2x square and so on till a2x square, a3x cube, and so on till an x power n, when n represents the the power, the index, and n is all natural numbers. a0, a1, a2, a power, all an represents your coefficients. They are all real numbers. Okay, then this is a function defined on all real numbers only, r to r. Okay, so the domain is all real, range is also all real depending upon the situations. It can be either, if you have power a degree as 2, it becomes a quadratic function. If it is 3, it becomes a cubic function, biquadratic or linear depending upon the power. If it is only till this point, linear. If you include this also, quadratic, cubic, biquadratic, and so on. Okay, rational function, when you have the function in the form of course fractions, fx by gx, we have provided gx is non-zero value. Gx is non-zero value. This is called as rational function. Okay, great. Modulus function, very commonly used, beta, very commonly used. These are two general functions. Okay, so we cannot draw the graph of these. We can draw the graph of 1 by x. We can draw the graph of quadratic, which will be a parabola. Linear will be a straight line. We can draw those graphs. Okay, but general we cannot draw the graph of. If somebody asks you draw a graph of polynomial function, so you'll ask us a degree, what degree is 1, 2, 3, what is it? Okay, so you got to ask. These are general forms, so that's why we don't have graph for first two. Okay, rational function, again there is no standard graph, because only if they say no that 1 by x is there, 2 by x is there, then we can draw the graphs. Make sense? Okay. Modulus function, the graph for this is there. Y equal to mod of x, when x is all more than 0, it is coming as positive value, so x only. When x is negative, means I have to make it positive, so you introduce minus x to get the result 0. And the graph is what? Y equal to x line on the positive side, y equal to minus x line on the negative side of the y-axis. Please check. Okay, and what is the domain over here? Domain is all real numbers. And what is the range over here? All non-negative, means negative part has to be removed. Okay, means if you talk about range, from all real numbers remove the negative real numbers. From all real numbers remove the negative real numbers. 0 will be there. That's why I have not said that. Just remove or simply write positive real numbers. The range is not positive real numbers, because even 0 is present over there. 0 is not a positive real number. Okay, so if you're writing 0, if you're writing positive real numbers, you have to add 0 over there, or simply from the real number remove the negative real numbers. Signum function, a signum function. Okay, special definition is there. We define it like this: mod of x by x, it comes out to be -1 for all x less than 0, +1 for all x more than 0. Of course, I hope you understand this. Check here. If x is more than 0, mod of x becomes x. Then mod of x by x becomes x by x. Answer is 1. When x is less than 0, mod of x becomes minus x. Then this becomes mod of x by x becomes minus x upon x. Answer is -1. So for all x less than 0, it is -1. For all x more than 0, it is 1. And for x equal to 0, what happens? You got to find the limiting value. This is always going to be 0 only. Okay, this signum function. The domain is all real number, but the range is 3 elemental value, and the graph looks like this. The graph looks like this. This is open over here, by the way. Here also it is open. Okay, this is your positive infinity side, negative infinity side, and at 0 it is 0. this is 0. So answer is minus 0 and 1, minus 1, 0 and 1, and the range is minus 1, 0 and 1, and domain is all real numbers. Domain is all real numbers. Is it making sense? I hope it does. Next is GI of x. Okay, means greatest integer function of x. Over here, the result is always an integer. If you have to draw the curve, I hope it makes sense to all of you. Please check. This is the x-axis, y-axis, x dash or negative x-axis, y dash or negative y-axis. Okay, check here. This is the origin. So the graph looks like this. At 0 it is 0, then goes till 1 like this, open, then there's a jump, close, open, jump, close, open, step function basically. Okay, this is incorrect, let me erase this, and so on. I have to go backwards as well. Close. This is the graph beta. Let's draw the numbers also. So 1, 2, 3. Okay, this will be 4 actually. This will be 4. This will be again 1. This will be 2, 3. This will be minus 1, minus 2, and minus 3. Over here also minus 1, minus 2, and minus 3. Okay. So at every integer, what happens over here is basically, check this out. After 1, it goes to 1, means whether you put 1.1, 1.2, 1.3, if in the function you put 1.1, what is the answer? 1. 1.2, answer is 1. 1.9, answer is 1. 1.999, what is the answer? 1 only. For 2.0, answer is 2. 2.1, answer is 2, and so on. Okay, I hope this makes sense. So everything before 2 answer will be 1, after 2 answer will be 2. Okay, got it? Answer will be 2. This is a step function or GIF of x, means greatest integer function of x. Domain is all real. Domain is all real. Range is only integers. Range is only integers. Check here. Starting from all the negative values, so minus infinity to plus infinity, only integers, minus 3, minus 2, minus 1. Okay, so only integers. Exponential function, again we have 2 cases over here. So this will never go 0 or below 0 exact, 0 below negative or below 0 value. First curve looks like this. Okay, if I write a par x, this is the value of a more than 1. Okay, right? This never touches x-axis, negative, okay, or anything. Another curve is like this. This is a par x again. In this case, the value of a is more than 0 but less than 1. More than 0 and less than 1. Okay. Again, this point, I hope you know this, 0, 1. This point is also 0, 1. This graph never touches x-axis, never. And it has 2 cases. When the base is between 0 and 1, the curve is of decreasing nature. When base is more than 1, the curve is of the increasing nature. And the special case, which is exponential function, natural base, this is always, one second, if you take the e power x case, which is what? E value is more than 1, no, it's 2.67 something. This comes like this. Again, 0, 1 only. This is e power x. So e power x resembles over here something like this. Okay, because e value is more than 1. Because e value is more than 1. Okay, makes sense. Again, never touches x-axis. Next, domain is all real. Range is only positive value. Domain is all real. Range is only 0 to infinity, so positive value. One more thing, a can never be equal to 1. A can never be equal to 1. A is not the range or domain, A is the base. Okay. Logarithmic function. Okay, this also has 2 beautiful graphs. Have a look. One is this one. This is for log of x with the base a Condition is a more than 1 and x of course has to be more than 0 only. X is never negative or never 0 in the case of logarithmic function. Okay, you cannot find log for 0 or negative values. Only for positive value you can find the logarithms, and the base has to be more than 1 for this kind of curve. This point is 0, 1, sorry, 1, 0. So log 1 is 0, so 1, 0, and the other curve is this one, decreasing case. And I hope you know by now, this is, sir, again 1, 0, log of x with the base, say x of course more than 0. What about a between 0 and 1? Between 0 and 1. Okay, please check. Between 0 and 1. Yeah, again this never touches y-axis. Either cases doesn't touch y-axis. Range is again all real numbers, goes from where to where, sir? Negative infinity to positive infinity. But domain is only positive values. Domain is only positive, range is all real. Okay, next question on this. Let's solve a question on this. If the domain of a function fx equals to x square minus 6x plus 7 is given, okay, this is a polynomial function. I'm looking for domain. Then the range of the function is what? Okay, range of the function is what? We know that this is a upward parabola. F of x means this is a upward parabola. Okay, upward parabola. One more thing, if I go about this, can I make a whole square of this? It makes sense to me. Minus 2 into 3 into x, correct na? That is minus 6x. So it means I need to add plus 3 square and remove minus 3 square, and plus 7 remains as it is. Correct, because I'm looking for the range, so I can make perfect square become much easier for me. You'll see. So I get here x minus 3 the whole square minus 9 plus 7. Yeah, so far so good. Making perfect square, bacha. X minus 3 the whole square minus 2. This is your f of x. Again, this is one of the approach of using what? Perfect square method, or you can simply find what? This is the upward parabola. So find the vertex of this parabola. Find the vertex of this parabola, you get the result. Okay? Getting it, no? Yes. Yeah. So when you put x as let's say 0, you get 7 only. And when you solve it, no, you can't solve. You'll not get numbers directly. It's not factorizable, no, because we have 7 minus 6. How will you plot it? 7 minus 7 plus 1. Yeah, we can do that. Minus 7 plus 1, something like this. So I think the curve should be minus 7 plus 1. I want to write minus 7 plus 1 x square minus 7x plus x plus 7. But no, it is not factorizable because I'm gonna get, no, not possible. No other factors are possible actually. We can't factorize this. We cannot factorize this. But yeah, you can find the vertex minus d by 2a formula. Minus d by 2a formula you can use. Okay, you'll get a value over here. Then find f of minus b by 2a. You'll get vertex. I'm just giving you a multiple approach. We can get the answer from here. I'm going to solve this method only, but I'm giving you the approach. Find the vertex. Vertex will be what? Upward parabola means something like this will come, right? Means this value will be, this vertex that you get, the y coordinate, this or more. It's going to be increasing only. Okay, so same way. So you're getting over here, check this out. This is a square value. Means minimum value of this, if I want to find f of x minimum. Think about it. Minimum value if I want to find out. Minimum. Okay, 1 second guys. Use logic. Because you're learning for KCET, right? So use logic. I'm looking to find the minimum value of this function. This function minimum will occur when it is 0. How come, sir? Think about it. Think about it. If you take any other value, take 1. What will happen? It will become some positive value, minus 2. Will it increase or decrease? It will increase, no? You have some positive value over here. You're going to add up to minus 2. It will increase. Right? Think about it. If I take here 4 minus 3, what is the answer? 1. 1 minus 2 is how much? Minus 1. When you put 0, when you put x as 3, it will become 0. What is the answer? Minus 2. So earlier it is more, or minus 2 is higher, or minus 1 is higher? Minus 1 is higher. So any positive value will increase the value of f of x. Any positive value of this will increase the value of f of x. Means the minimum will occur when this is 0. Yes, the minimum of fx will occur when this is 0, and this is 0 when x is minus 3. When x is 3, when x is 3 means it will become 0. So the minimum value is actually minus 2. What about maximum value? X is all real numbers. I can put any value. I can put infinity also. Put infinity. What is the answer going to be? So f max, fx max, if you check, you'll get the value to be going to plus infinity. Because domain is all real numbers, I can put any value. Put 100 over here. You'll get 100 minus 3 the whole square. So 97 the whole square minus 2, a very big number, right? So the fx maximum is up to infinity. Fx minimum is only minus 2. So the answer becomes what better? Minus 2 close to infinity open. Answer is A. This is completely a logical question. Using perfect square method, this question comes in within few seconds. Okay? You can use formula method also. Both will give the same result. Answer is option A. Okay? If f of x plus 1 by x is x square plus 1 by x square minus 1, x not equal to 0 of course, then find f of x. Okay? Of course we need to know that we have to replace it. Substitute this whole thing as something. Good that we already have a result over here. This will make an identity if I have plus 2. It will become whole square in that case. Yeah. We can't do it on our choice. Something extra we have added. I have to remove that. Yes or no? Added plus 2, I have to remove the 2 from there. So I have added the minus 2 also. Check this out. This is making an identity. So x plus 1 by x the whole square. This minus 2 as it is and minus 1. I'm getting here x plus 1 by x the whole square minus 3. And this is f of x plus 1 by x. Take x plus 1 by x as t. Replace it. You'll get f of t equals to t square minus 3. Now you know that in the function I can replace any variable. I can replace this t to x. Don't think so this is not substitution, this is replacement, okay? This is not substitution. No. This is basically replacement, okay? This is replacing the variable. Replacing variables. Okay? T to x, I get the answer as f of x equals to x square minus 3. Answer is option C. Okay? Simple. Have a look. Okay, moving on. Find the domain and range of the function f of x is 2x square minus 1. 2x square minus 1. Domain. It's a polynomial function. Domain. Polynomial function. Remember, always real. This is domain, right? Always real number, all real numbers. What about range? What about range? No problem, sir. Think about it. This can go to what? Minimum find you. This is again a upward parabola. This is also upward parabola. Quadratic is there, right? 2x square minus 1 is a quadratic, upward parabola. So again find the minimum value. So f of x minimum you find. Again will be when x square is 0, add 0. So this is going to be minus 1. Think logically. Put any other value. Let's say put x as 1 or minus 1, whatever you want to put. You get 2 into 1. 2 minus 1 is what? 1 now. So that is again increasing value. If you take f of 1, sir, answer is what? 1. Take f of 0, sir. Answer is what? Minus 1. So the minimum value is minus 1. Everything else, if you try to put f of 2, put f of 2, you get 2 square into 2. So 8 minus 1 which is 7. Put f of minus 1 just to be sure. Minus 1 square is again 1. 1 into 2 is 2. 2 minus 1 is 1. So only the minimum value is this. So minus 1 is the minimum value. Everything else is more than that. So minus 1 to what? Infinity. Minus 1 to infinity. Answer is option B. Domain is all real ranges minus 1 to infinity. Make sense? Please check. Have a look. Done. The domain of the function fx equals to log of, with the log of something with the base 2, again log of something with the base 3, log of x with the base 4. Okay, so for the first log to be defined, for this I'm going to write this again. So log of 2, log with the base 3, log of x with the base 4. For this first log to be defined, what's the condition? First log I'm talking about. The condition is this value has to be positive. Log is not defined for negative number, so means this value over here, this value has to be positive, and this has to be what? Not equal to 1. Base cannot be 1. We learned that. Okay, base cannot be 1. Okay. Actually, I did not write that over there, but yeah, in log of x with the base a can never be equal to 1. A can never be equal to 1. Okay, that is one understanding. Okay, and of course cannot be 0, less than 0 also. Okay, between 0 and 1 and more than 1. Great, sir. So once we have this result, it means this is clear. Log with the base 2 is okay, no problem. It is not negative, it is not 1. So both conditions are validated over here. For the base, a should not be equal to 1 and should not be less than 0. Okay. Now check over here, means only this thing is what we need to work on. So log with the base 3, log of x with the base 4 should be more than 0. More than 0. Okay. Now in this, simply apply what? Base change result. Okay, means log to exponential function. When you do that, when you apply log in that case, what happens over here? This 3 moves over here. You can eliminate this log and write here 3 power 0, this as it is, and over here you'll have what? Log of x with the base 4. Means this outside log has moved on this side as exponential function. Okay, 3 with the power 0. Same base, remember this result I'm using. Log of x with the base a equals to y, let's say we have, then I write x equals to what? A power y. Think, compare this. This x represents this log over here. The base goes over here with the power on the right hand side. Power was 0, comes on the right hand side. Same I have used. Conversion of log to what? The exponential function. Okay, 3 power 0 is what, sir? 3 power 0 is 1. Write this one more time. Log of x with the base 4 is more than 1. Same thing again you're going to apply now. Same thing again you're going to apply now. You'll have again x left over here, more than 4 power 1. It means x is more than 4. More than 4 is option B. X is more than 4 is option B. Have a look, please. Clear? Okay. Is this done? All right.